Hello everyone, my name is Venu. I am currently pursuing BTech final year in the stream of ECE at RVR and JC College of Engineering, Guntur, Andhra Pradesh. So first of all, I will thanking Team Emertxe for giving us this wonderful opportunity to gain practical experience on C programming as well as embedded programming. So during this internship, we have taught these concepts like introduction to C programming and various conditional statements and loops and operators. And later, we have taught with arrays and pointers. And during this internship, we have learned introduction to embedded systems and microcontrollers, specifically PIC16F877A microcontroller. And during this internship, we have interfaced various peripherals with PIC16F877A microcontroller. So in this video, I'm discussing about these two concepts like embedded system and its types and various peripherals which are used to do the project during this internship, like difference between microcontroller and microprocessor and CLCD display and matrix keypad and interrupts as well as timers. Later, I will show you the project demonstration that I have done during this internship. First of all, what is an embedded system? Embedded system is nothing but a combination of hardware and software which is intended to do a specific task, which is mean that to a microcontroller various peripherals are interfaced to do a specific task. For a general purpose system, it is used to perform a large number of tasks, like various tasks it should be implemented. But in embedded system, the microcontroller are interfaced with various peripherals to do a specific task only. There are various embedded systems like these are the different types of embedded systems like standalone embedded system, real-time embedded system, and networked embedded system, and mobile embedded system. A standard embedded system is any application or software that does not need to be bundled with other software or application, and it does not require any internet services. So it's basically a standalone device which does not follow the network protocol. Like there is no internet that is connected to this system. A real-time system means that the system is subjected to real time. For example, flight control system or real-time monitoring system. Next is network system, where the internet is connected here. For example, home automation system, where we are controlling the light appliances, home appliances like light, geyser, or doorbell using the mobile phone or any Wi-Fi control device. Next is difference between a microcontroller and a microprocessor. Microcontroller is a small and low-cost microcomputer which is designed to perform the specific task of embedded system, like displaying information, receiving remote signals, etc. So microcontroller is nothing but a CPU and external peripherals like memory and I/O ports and timers or interrupt controllers are all embedded in a single chip. But coming to microprocessor, microprocessor is a controlling unit of microcomputer fabricated on a small chip capable of performing arithmetic and logical unit. So basically in microprocessor there exists a CPU. Inside CPU there are ALU, control unit and register array, but it doesn't contain any peripherals like memory unit. We need to externally include the memory unit for this microprocessor. So as discussed earlier, in microcontroller, all components will be in single chip and less flexible and less design complexity. In microprocessor, all components are assembled separately. So coming to CLCD display, it is a liquid crystal display. It's of two types, like 16x2 display and 16x4 display. It displays any 8-bit character like ASCII character and some special characters as well. We can configure this LCD in two modes like 4-bit mode and 8-bit mode. So as I said earlier, this LCD display will display the any 8-bit characters, right? Say 8-bit data. We can display we can display by using 4-bit mode as well. So this is the matrix keypad. So there are rows and as well as columns here. When we press the switch, it's activated, and when we disable it, it is disabled. So interrupts. So interrupts is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests the CPU to stop the processing. So basically, whenever an interrupt occur from external or internal sources, the CPU must suspend the current execution process and respond to the particular interrupt. Then the MP or CPU acknowledges the request and attends to the request. Goes back to the processing where it has got interrupted. So ISR is nothing but interrupt service routine, which is a software routine used to handle that particular interrupt. ISR attends to the request of an interrupting source by clearing the interrupt flag and should save register content that may be affected by the code in the ISR. It must be terminated with the instruction RETIE. So basically, whenever an interrupt occurs to the microprocessor, the microprocessor or CPU will suspend the current execution process and attend to that interrupt service routine. Before going to the execute the interrupt service routine, microprocessor need to do certain tasks like uh, clearing the interrupt flag and save the contents of registers, because in order to save the contents. Timers is basically an important application in any embedded system, which is default peripheral, which maintains the timing of an operation in sync with a system clock or external clock. It has many applications such as measuring time and generating delays, etc. So basically, these timers are used to count the operation or the number of clock pulses applied. So software and hardware that is used in this project during this internship are: software is Pixim Lab, where there is a hardware development board. By applying code, we can simulate the code by using this Pixim Lab IDE, Pixim Lab software. MP Lab XIDE, we are using this software in order to code the microcontroller using C language. XC8 compiler is used to compile the C code. So hardware that is using is PIC16F877A microcontroller. We are programming this microcontroller to do the project. So now I will show you the demo of the project that I have done during the internship. Our project is about washing machine simulation. So I will show you now. So this is the PiximLab IDE. This is the Pic Genius board, where the microcontroller used is PIC16F877A. So I will load the X file that is written in C language. So here in the crystal display, it is showing that press key 5 to power on washing machine. So here it is switch 1, it is switch 2, it is switch 3, switch 4, it is switch 5 and switch 6. When I press switch 5, we can see that the washing machine is powering on. It is displayed powering on washing machine. Now this is the selection main menu section, where we have to select the options like daily or heavy or delicates. We can navigate to the options by clicking switch 4. You can see that it is switched to heavy, and then when I press again, it switched to delicates. When I press again, it switched to whites. So when we long press this switch 4, we can see that water level option is displaying. Let's wait for a second. Yeah, we can see that water level option is displaying. Here we also lot of options like auto, low or medium. We can navigate it by pressing switch 4. We can see we are navigating it. So auto, low, medium. When we long press this switch 4, we can see that further option is appeared. Let's wait it. Yeah. press switch 5 to start and switch 6 to stop. So I am pressing switch 5 so that the program is starting. So you can see that we have selected whites. So we can see the washing machine is turned on. So it is displaying the time left like 1 minute 9 seconds. By pressing switch 5, we can fetching switch 6, we can pause the operation. By pressing switch 5, you can resume the operation. We can see that. So by pressing switch 6, we can see that the washing machine is stopped. And when we press switch 5, the washing machine is resumed. So when we press switch 1, the door state is indicated. You can see that. So it's displayed door is open and please close. When we release it, it is continued basically. So this is the project we have implemented. Let's wait until the program is completed. So here we can see the time is decremented, and the function is the function. We have three functions like wash, rinse, and dry. So time is set for that. So you can see the time is decrementing here. Yeah, 20 seconds left. So the washing machine is running continuously. When we press switch 6, it is stopped or paused. You can see that it is paused. When we press switch 5, it is resumed. Yeah, we can see that the function is switched to spin, and the remaining time is 4 seconds. So you can see that the program is completed. Remove clothes. So now you can see that the program is completed. So now I will show you the code that is written for this project. So this is the MPLAB IDE where we have written the code for the microcontroller PIC16F877A. So this is the header file that is included, and these are the header files for CLCD and digital keypad, and also the timer. First we initialized the digital keypad and call that particular function, and also the LCD display. Next we can see that the operating mode is set for washing program. These are all the uh, available options that we can switch in washing program. These are all the available options, and in water we can see that these are all the available options. Now in the main program, first of all we will displaying press key 5 to power on the washing machine, and we will reading this switch from the digital keypad function. When we press switch 5, the program on screen is called, function is called, and it is called here, and we can see it is displayed powering on washing machine, and it will wait for particular time. Now after the power on screen, again we are reading the keypad status. Now if the key is switch 4 and operating mode is washing program, we are setting the operating mode as water level. So we are switching between the options, operation modes. Like in the previous it is washing program, right? Now it is water level. If we will long press the switch 4. So here it is the switch case where we are navigating to the options. When it is washing program, it would call the function like washing program display. If it is the water level operating mode, it will call the water level display function. Now in start stop screen, the key is switch 5, then operating mode goes to start program, and here it is start program, then the function run program is executed. So here we will see the washing program display. If we press switch 4, we can see that the program number is incremented, so we can switch navigate to the options like we can see earlier like daily, heavy. We can navigate through these options by pressing switch 4. In water level function, same is implemented. If we press switch 4, the water level index is incremented so that we can navigate to the options. So this is the entire code that is written for the project. So thank you so much.